Hi, everybody. Welcome back to Are We on the Same Page? I'm your host, Dave Thomas Rocker, and this is my fourth and last video in my series on future inventions, predicted future inventions. And today I'm going to talk about 10 inventions that I'm predicting we'll have by the second half of the 22nd century. And unfortunately, I think most of us, maybe none of us will be alive by then, but maybe our children, our grandchildren will, and so maybe they'll be able to enjoy this future. And if we live long enough, maybe even some of us will. We'll have to wait and see. But anyway, let's begin. Before I do, I want to give another plug for my book, My Spiritual Journey. You can find this on Amazon. It's better to look for my pen name, Dave Thomas Rocker, because I think there's other books on Amazon called My Spiritual Journey. But it's about a 100-page book. It's mostly one-line quotes about how to live a good life and about some of my spiritual views and kind of what matters in life. And you might be interested in it. Anyway, it's available both in paperback and for Kindle, and you can buy it on Amazon. I think it's $30 paperback, $9 Kindle. You might want to check it out. Anyway, that's a plug for my book. And now let's begin the video. Before I get into the what I consider the 10 greatest predicted inventions of the latter half of the 22nd century, I want to give you guys a little bit of an overview here. I've divided the future, at least the next 175 years, into four eras. That's as far as I care to predict. I can't even imagine what will happen beyond the 22nd century. I think it'll involve mostly technologies we can't even imagine today, just like people from the 18th or 19th century could barely imagine what the technologies that we have today. Uh, this is about the limits of my imagination. Maybe some of you guys can imagine more, but I can't. So anyway, I did my first series maybe about 2 months ago on the very near future. These are probably easiest to predict. This will be the next 25 years from 2025 to 2049. And all these, I had five inventions for this period because it's a shorter period. It's just 25 years. All the other ones are 50 years. So I featured 10 inventions for the other three. And I think I should talk about the pictures as well. So the picture on the top left is supposed to be a depiction of a large city sometime in the near future. It doesn't look too much different from cities today. And this is on Earth, unlike all the other three pictures, which are in various places in outer space. Anyway, the next era is the what I'm calling the near future. That would be the second half of this century, 21st century, from 2050 to 2099. And I talked about 10 predicted inventions from that era. And the picture in this for this era I show here is supposed to be a Mars colony. I guess in the near future it might look something like this with a hyperloop and also with kind of some habitats in the background. That's what we might be able to see on Mars by then. Although I think most of us will still be living on Earth, fixing the problems we have here today, hopefully. And then what I'm calling the distant future is the first half of the 22nd century. And the picture I'm showing here is the interior of a space colony. This would be a city in outer space, not on the surface of a moon or a planet, but just floating freely in outer space. And Gerard O'Neill was a big pioneer of these things. He came up with this design called the O'Neill cylinder, which I prefer to the picture I'm showing here. The one shown here is not one of his designs. It's a torus, like the interior of a donut. And the disadvantage to this design is that you would feel normal Earth weight everywhere in this colony, whereas with the O'Neill cylinder, you could vary the amount of weight you feel. But anyway, that's just a depiction of what I think we can expect in the first half of the 22nd century. And by the way, this is all dependent on not having a catastrophe, which we might well have. I mean, assuming we survive as a species, and even if we do survive, assuming that we don't have some major world catastrophe, which is very likely, then we will probably see all this stuff that I'm talking about here. And let's just hope that we do. I don't want to have a big disaster, although I think the 21st century is probably going to be the most challenging century for humanity that we've ever experienced. It could determine whether or not we experience another dark age or the end of our whole civilization. Let's hope we don't have that. Anyway, the last picture here is a depiction of what I call the very distant future, which would be the second half of the 22nd century, i.e., from 2150 to 2199. And the picture I'm showing here is supposed to represent a colony on another star system, maybe Alpha Centauri or a nearby star. And it's we've discovered a lot of exoplanets in recent years, so now we know that most stars, at least in the Milky Way, have plants around them, and probably a lot of them are habitable. So we might see something like this by the end of the 22nd century. Although I think maybe none of us will live to see it, but we'll see. Anyway, those are kind of just pictures of the different eras. And now I'm going to talk about the fourth of these, which is the last of my series, namely the very distant future, 2150 to 2199. So the 10th most important invention that I predict during that era is you guys probably this probably doesn't mean anything to you, but this is a very important thing in math. It's called the Langlands program. And this was actually devised by a famous mathematician named, I forget his first name, Robert Langlands in 1970. And this would represent kind of a unified theory of mathematics. And we've already made strides in this direction, which is kind of interesting to me. I mean, I think the latest of these strides was what's called the modularity theorem. This was proven in 2001 by a very famous, maybe the most famous, world's most famous living mathematician right now. Maybe some of you have heard of this guy, Andrew Wiles. He proved two very important mathematical results. In 1995, he proved an unsolved problem in math that was almost 400 years old, namely Fermat's last theorem. A to the n plus b to the n equals c to the n. There was a famous 17th century mathematician, Fermat, I guess a French mathematician, who Pierre de Fermat, who hypothesized that this equation had no solutions in integers where n was greater than or equal to 3. And he said he had a proof, but he didn't have enough room to write it down. I think nobody believes anymore that he did prove this, but Andrew Wiles did almost 400 years later using some of the most advanced mathematics that was known at the time, and I think still is known. And this is just a small part of this Langlands program. And another thing he did, he actually came up with another result in 2001, which included his theorem that he proved from Ma's last theorem, but it was more what's the word, comprehensive. He proved that all elliptic curves. He proved that basically elliptic curves and modular forms are the same thing. I'm not going to try to explain what that means. I'm a mathematician. I have a PhD in math from UC Berkeley, so I know a lot of math. But that result in and of itself is just a part of this Langlands program. Basically, this Langlands program would unify geometry, more specifically algebraic geometry, which is a very advanced area of geometry. But it would basically unify geometry with algebra. I think you guys know what algebra and geometry are, at least at the kind of rudimentary level you learn in grade school and high school. I mean, algebra or arithmetic, they're kind of the same thing. That involves discrete things like numbers and sets. And geometry involves continuous things like space, like different different shapes. Shapes are continuous. And what's remarkable is that this Langland's program, this mathematician Langland's, believed that there's a unification between discrete math and continuous math, which is pretty remarkable. I mean, they're very different ways of viewing math. I mean, they seem to involve different concepts, but according to Langland's, they're really the same thing. And so, this is a big project, and it may be completed way before the second half of the 22nd century. It's almost impossible to predict when unsolved mathematical problems will be solved. We really don't know because we don't know what kind of brilliant insights lie ahead. But I mean, I'm just kind of throwing this out as something that I think will get done by the end of the 22nd century. Maybe I'm wrong. It might even be impossible to do this. Maybe this is wrong. Maybe Langland's had the wrong insight, and maybe what he's proposing here isn't possible. We'll see. We'll just have to wait and see. So this one's, I think, a pretty big long shot, but to me, it's interesting. Maybe I'll only put it at number 10 because it's not really practical, at least in any way we know right now. But anyway, now I'm going to get into some more wild ones and I think some more mind intriguing ones. Number 9 is what I call a time viewer. And this is not as radical an idea of time travel. I will get to time travel later, but even if time travel were not possible, if it wasn't possible to travel into the past, which a lot of people, a lot of serious physicists believe it is impossible to go back in time, and there's good reasons to believe that, which I'll get into later. But being able to see the past, that's a whole different ball of wax. I mean, that doesn't involve any paradoxes, and this would revolutionize history. And the picture I show here, I don't know how many guys recognize. This is a picture from a very excellent episode of the Star Trek, the original series. I think it's my favorite episode. It's called "The City on the Edge of Forever," and they go to this planet and they discover this time machine. And before they discover it's a time machine, it just looks like a time viewer. I mean, what this thing does is it shows them all these eras from the past. It basically shows the whole history of humanity played, rapidly, showing different things from history. And what they're looking at here looks like a scene from the 19th century. It looks like somebody riding a horse and carriage, and they're wearing top hats, so that's probably Victorian England or something. But the Star Trek crew is kind of mesmerized by this. I don't know how many guys saw this episode. I guess Bones, Dr. McCoy accidentally injected himself with some bad drug and he goes crazy and he jumps into the machine in 1930 and alters history and jeopardizes the existence of the Enterprise crew by accidentally triggering Hitler's victory in World War II. Very excellent episode. I think I already spoiled a lot of it, but anyway, aside from him jumping in and actually traveling to the past, they were watching it. And it shouldn't be a problem to watch the past. We just don't know how to do this yet. But I believe it will be possible someday, and this will clear up a lot of myths. I think we'll learn that a lot of what we think we know about history is wrong, or at least exaggerated. We're going to learn the truth about the past, including the Bible. And I know I'm probably going to upset a lot of religious people here, but I think we're going to learn firsthand that the Bible is just a bunch of myths, that practically none of that really happened. Yeah. So, anyway, I'm looking forward to this. I don't know if I'll live to see it, but I wouldn't mind seeing the Bible disproven. Anyway, number 8, propertyless society. This is one I really like. And this may be a long shot, I don't know. This is another thing that's predicted on Star Trek, by the way. In the Star Trek universe, they don't use money and they don't have property. All humanity, lives, sharing all money and all wealth and all property, and they're devoted to just intellectual pursuits and philosophical pursuits and living in harmony, which I think is really a utopia. I can't imagine much better for society than that. And there is a line from the song Imagine by John Lennon. The last verse he starts out, Imagine no possessions. I wonder if you can. Most of us don't think about sister society because we're so used to having possessions and we seem to need them. But I think someday we won't have them and we'll be so much better off without them. And the picture I'm showing on the right, I just learned this today. This is actually a model that some sociologist, I guess, came up with. I forget what they call this thing. Like a three-state system or something. It just shows the interactions kind of between social, political, and economic aspects of society and how they would ideally interact with each other in a propertyless society. So I think we should try to strive for something like this. And I don't think this picture even represents a propertyless society. I think there's still property in the society. And, I mean, we have to be careful because this was kind of the idea Karl Marx had with communism. And as we all know, communism didn't work. We've never had a successful communist society, and I don't think I'd even want to live in one. I'm not a commie. I am a socialist, but I'm not a commie. And I believe in democracy. And I actually think that socialism works better with democracy than capitalism. I think capitalism is about to destroy itself. And I think it'll get replaced with socialism, but we're still going to have money and property for a while, even with socialism. And I can live with that as long as we level the playing field a little bit. Anyway, that's propertyless society. Maybe I should have ranked this one higher. I don't know. But number 7, artificial senses. This one's very similar to one I featured in my last video. I had bionic implants. And I don't know how you guys remember the $6 million man. He actually had a bionic eye. So he did have an artificial sense. He had a special eye that he could allow him to see things that were much farther away than a human eye. And I think that the bionic woman, she had a bionic ear, so she could hear. She had like superhuman hearing. Not only could she hear things from a very large distance, but she could hear higher and lower frequencies as well. And I guess I mean I think that by the second half of the 22nd century, we won't only have bionic implants that'll increase our physical strength or dexterity. We'll also be able to enhance our senses, and I think this is even more exciting because I mean, so our senses are very limited if you think about it. I mean, our eyes only see one octave of the electromagnetic spectrum. There's about 80 octaves of the electromagnetic spectrum. So we can only see about 1/80th of all electromagnetic waves that we know of. Imagine being able to see X-rays or being able to see radio waves or, stuff like that. And maybe, I mean, there are animals that have, the human eye only sees 3 primary colors. There are other animals that see, I think, up to 11 primary colors. And there's actually infinitely many primary colors of real light. So there's a lot of there's a lot of colors we don't even see. We don't even perceive. That's just vision. And then our other senses. I mean, imagine being able to hear frequencies in the millions or billions of hertz, or maybe very, very low frequency. Maybe imagine being able to hear planets orbit the sun or something. We don't know. I mean, just a matter of your imagination. Just imagine how enhanced your senses. I mean, we already have equipment that can do a lot of this stuff. We have telescopes and microscopes, telescopes that can peer to the basically the edge of the known universe, observable universe, and we can see elementary particles that are like 10 to the minus 18 meters. I mean, imagine being able to do this, experiencing it yourself. I mean, pretty wild, I think. And maybe there's even other senses we could create for ourselves. We have 5, but why just 5? Maybe there's some other types of senses too we just haven't thought about. So I think this is a really exciting one. And number 6, interstellar colony. I use the same picture here that I used for the cover slide, and I already explained what this picture is as a depiction of an interstellar colony, a colony on another star system, another planet, another star system. And I think, I mean, this is really just an extension of the idea I did in my last video of space, or 2 videos ago, I think, of O'Neill's vision of space colonies. I mean, the first space colonies will just be in our own solar system. But, as we continue to build them, eventually at some point, we'll probably venture out to another star system. We'll probably start with Alpha Centauri, since that's the closest star system to our own, about 4.2 light years away. And by the way, I really don't like how a lot of sci-fi writers try to get around the speed of light. I mean, it just seems like just about every sci-fi story I've ever seen, including the Star Trek series, that involves travel to other star systems, they all imagine that someday we'll figure out how to travel faster than the speed of light. And I really don't like that because that violates the Einstein's theory, both the special and general theory of relativity. And it involves a lot of paradoxes according to that theory. So I just don't like the idea of violating the speed of light. If it's any consolation, the twin paradox will allow you to travel near the speed of light without aging. So, you might be able to travel to the edge of the Milky Way galaxy within your lifetime, although if you ever return to Earth, it would be 100,000 years later. But, I'm talking about time as measured on Earth, and of course, time is relative. All these years I'm giving, by the way, you kind of have to take them with a grain of salt, because once we start going to other star systems, it won't even make sense to talk about what year it is. It'll depend on how you're moving. So we won't, there's no universal clock. Einstein proved this. There's no universal clock. There's no Greenwich Mean Time for the whole universe, or even for the Milky Way galaxy, or even for the nearby stars. If we're measuring time on Alpha Centauri, we're going to have to be very careful about how we measure it. Time, they'll have their own calendar that's, independent of the Earth's calendar, and it won't even make sense to compare them. But aside from all that, if we're measuring time on Earth in some consistent way, um, with the speed of light barrier, even if we started venturing to another star system at the beginning of the 22nd century, which I think is kind of unlikely after me, even if we did that, we'd only have 100 years to travel, and if the speed of light truly is the fundamental speed limit of the universe, we wouldn't be able to go out more than 100 light years, and probably a lot less than that. The good news is that there's a lot of star systems within 100 light years. I think there's thousands of them. So we'll still have a lot of places to go. But just it'll take a lot longer than you might want. But I think it's still exciting. I think we will do some of this by the end of the 22nd century, at least as measured on Earth. So that's interstellar colonies. And number 5, kind of similar, but this is a little bit farther out. This extraterrestrial alliance, and of course, this depends on the existence of extraterrestrial intelligence. I mean, or extraterrestrial life. We still haven't discovered any aliens, and I think they are out there. I mean, I'm like 99.999. I don't even know how many nines to put at the end, but I'm virtually certain that there is other extraterrestrial life in the universe besides us. The universe is really, 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 really big. Just not the observable. In the Milky Way galaxy. And there's a thing called the Drake equation. I don't know how many guys are familiar with this, but in the early 60s, there was an astrophysicist named Drake who estimated, and it is a very hand waving ballpark estimate, but he multiplied these six factors together and came up with an estimate for the number of intelligent extraterrestrial civilizations in our own Milky Way galaxy. And I think he came up with a figure of somewhere between, I think it was between 1,000 and 1,000,000. I mean, according to his equations, it was virtually certain that there was other intelligent extraterrestrial civilizations in our own Milky Way. And then the question became, where is everybody? The Fermi paradox. And we still haven't come up with a resolution of the Fermi paradox. I mean, if extraterrestrial intelligence is as common as Drake, expected it would be, why haven't we seen him yet? And I think there's a lot of reasons, actually. I think I can think of a couple good reasons. One is that, for one starters, if you consider the whole Milky Way galaxy, you have to keep in mind again the finite value of the speed of light. I mean, if suppose there was an extraterrestrial an intelligent civilization halfway across the Milky Way galaxy from us, that would be like 50,000 light years. That means they would see us as we looked 50,000 years ago. And they probably wouldn't be interested in us if they could see us at all because we'd still be cavemen, you know. But I mean, the only ones that would be able to see the signals that we've been sending out would have to be within about 100 light years because that's we've only had radio for about 100 years. So radio and TV. So the probably the only ones that are even seeing us trying to communicate with them would be within 100 light years, and there aren't that many stars within 100 light years. There's a few thousand. I think maybe a handful of those have extra intelligent life on them. That's another reason, and even if they were there, which I think they are, I think there probably are some aliens on some of these star systems that are watching us. But imagine, would you want to visit us if you were these aliens? If you were more advanced than us, and you see us still fighting wars, and you see Trump as president, and you see us, threatening our own existence, would you want to come here? I wouldn't. I mean, I think maybe they're testing us. Maybe they're watching us and seeing if we can make it through the great filter. And maybe they don't want to even contact us until we do. And if that's what they're doing, then I salute them because they're doing the right thing. They're waiting for us to get our act together. And basically, that's the plot of I don't know how many guys saw the movie The Day the Earth Stood Still. This is basically the plot of The Day the Earth Stood Still. I mean, that was a little more dramatic because there was an alien who visits Earth and he gives Earth an ultimatum at the very end of the movie. He says, "Join us in peace or be obliterated." And I don't think it's going to be like that. I think they're just not going to want to bother with us until we get our act together and achieve world peace. So once we achieve world peace, once we get our act together here on Earth, then we may expect to meet some aliens. I wouldn't be surprised. Anyway, that's something we can look forward to if we get our act together first, I think. Anyway. And once we do meet extraterrestrials, I don't see any reason why they wouldn't be friendly to us, especially if we get our act together. They probably did a long time ago. So they're probably waiting to make peace with us once we make peace with ourselves. You know. Yeah, so anyway, enough of that. Number four. Now we're getting some pretty wild stuff here. Artificially induced telekinesis. Why do I always say artificially induced? I mean, I don't think it's possible just with your own brain to move objects with your mind. I mean, this has been a very popular idea in sci-fi and fantasy stories, probably for most of human history. I mean, who hasn't wanted to lift or move objects with their mind, right? I've had a lot of dreams like this, and most of the dreams where I had telekinesis, I was kind of floating. I was mostly moving myself and meditating around a room. I don't know why I was doing that, but anyway, we've all dreamed of doing things like this. But here's the thing. I'm very, very well trained in physics. And there's something called the law of conservation of energy. Imagine you wanted to lift a big, huge boulder in the air with your mind. Well, the boulder, imagine it weighs a ton. You would have to exert that much force. You would have to exert the same amount of energy due to the conservation of energy. If you wanted to lift a boulder, say, to the roof, that would involve maybe, I don't know, like 1,000,000 joules of energy. That's a lot of energy. I mean, if you did this with your hands, you could maybe use pulleys. It would be like a whole day's work, and you'd be exhausted at the end. Well, if you were able to do it with your mind, you'd be just as exhausted because you'd be expending the same amount of energies with your brain instead of your muscles. So forget it. I mean, even if you could do this, you probably wouldn't want it. It would be too exhausting. You wouldn't be like Yoda being able to lift the Millennium Falcon out of the swamps. Sorry about that, but Yoda would be. He was just a little tiny alien. Can you imagine what that would have done to him? Lifting that Millennium Falcon. I just don't believe that. So, but maybe with machines we could do this. If we had the right kind of machinery and the machines were expending the energy instead of our brain, then maybe we could do this. Maybe we could tell a machine with our brain to move something, and maybe we could do it wirelessly. Maybe there's some kind of wireless technology we haven't discovered yet that can interact with ordinary objects through the air. Maybe using a magnetic field or some other field force we don't know about yet. Maybe we'll have some kind of field like they do in the movie Avatar that levitated the islands in the sky of those space islands. And they never explain how they did that, by the way. I think that was a big flaw with that movie. They should have invented some fictitious force field to be able to have that happen, and they didn't. So that was kind of a disappointment to me. Um, but I mean, you can't violate the laws of conservation of energy, and the law of conservation of energy cannot be violated. I mean, I can say that for a fact. I mean, that's a consequence of Noether's theorem, the symmetry of time of the universe. The law of conservation of energy cannot possibly be violated, and you can even write that on a monument if you want, because I stand by that full heartedly, and everything I know about physics confirms that. So you better have a machine to do your telekinesis, so you don't wipe yourself out. Anyway, that's artificially induced telekinesis. Number three, and another pretty wild sci-fi idea, mind transfer. This is another one that's appeared in a lot of sci-fi. We all know about Spock's ability to mind meld with other beings, but I'm not just talking about mind meld. I mean, I'm talking about actually transferring everything in your mind into another being or another machine. And why not? I mean, I don't see why this wouldn't be possible. We can't do it today. I mean, our brain has a lot of information. What we'd have to do is we'd have to transfer all the information in our brain into some kind of database. I'm thinking like, maybe the cloud. Now we have the cloud. Before it was just computer hardware, but now we can use the cloud. So maybe we could upload all the information in our brain into the cloud, and then maybe we could transfer that information into an Android or whatever you want. You could be your favorite Android. You could, I think it'd be much harder to do this with other biological beings because you'd have to transfer all the information into their brain, and it'd be kind of cool if you could do that. You could be another person. You could be a woman if you want. I think most people would like to, at least for a day, be someone of the opposite sex. I wouldn't mind, as long as I wasn't raped as a woman. But I wouldn't mind being someone else, or at least experiencing it for a little bit of time. I wouldn't mind being an android either. I think I'd prefer being an android because I'd be able to do a lot of things that humans can't do. Not permanently, but temporarily. Why not? And you could even be a dog, maybe. I think a lot of people would like to be a dog or a cat or whatever. You probably couldn't be an ant because their brains are too primitive, but you could be a being that has a similar brain to your own. I mean, I think even a dog would be a stretch because I think their brains are a lot smaller than human brains. So you'd probably be limited as a dog. But anyway, enough of that. And number two, now we're getting some really big ones here. Multi-dimensional travel. Why do I say multi-dimensional rather than just time travel? This would include time travel, by the way. And like I was saying earlier, I used to think time travel was impossible. When I first learned about time travel in the past, I was thinking to myself, no way, that's not possible at all. And there's a lot of reasons that a lot of people still think it's impossible to go back in time. It involves a lot of paradoxes. And I think I mentioned five of them on this slide. I think I can remember them all. The biggest one people talk about is what's called the grandfather paradox. If you could go back in time and kill your grandfather before your parents were born, then you wouldn't be born. And so that would create a logical paradox. You exist and you don't. But the way around that is you have to imagine that you're not only traveling backwards in time, but you're altering history. This is I think a newer idea in time travel stories. I think the first time travel stories didn't involve altering history, but I think most of the modern ones do, like the Back to the Future and Just about all the news stories about time travel in the past, you do change the past, you change history, and so things change when you go back to the present. How much they change is debatable. I think they'd change pretty significantly, but some people doubt that. I don't know, because we've never done it, so I guess that is a way to rescue. At least that resolves the grandfather paradox. But then there's other paradoxes, like there's a chicken and the egg paradox, also known as closed time loops. You could enter an infinite time loop where you keep repeating, going back and forth through time. I find that very disturbing. I wouldn't want to be in an infinite time loop. It's kind of like a form of hell, I think. But there are a lot of stories about that. I've seen some Doctor Who and some Star Trek episodes exploring that idea, and they figure out how to get out of it. Um, and I think that's even predicted in various models of general relativity, by the way. So that one may not be as far out as it seems. Then there's, the problem is if you go back in time, what happens if you meet yourself? Could you meet yourself an hour ago and bring yourself back to the present and keep doing it as many times as you want, ending up with as many copies of yourself as you want? That seems to be a problem. I mean, I think there's ways around that too, but maybe I'll just talk about this one a little bit because it's kind of fun. There is a theory that antimatter is matter traveling backward in time. There's a lot of good reasons in physics to believe this, actually. It acts like matter band traveling back one time. There's something called CPT in physics, charge, parity, and time. And according to this theory, antimatter is ordinary matter with its charge reversed. So the antimatter, because of an electron's a positron, it has a positive charge rather than a negative charge. Parity is reversed, so left and right get reversed. And the other thing that gets reversed is time. So according to that idea, a positron is really just an electron that's traveling backwards in time. Some people really believe this. I think even Feynman believes this. And you can think of a antiparticle annihilation. I think I talked about, matter, antimatter annihilation. When matter comes into contact with antimatter, they both annihilate each other and turn into energy. V equals mc squared. One way to think about what's happening is that the electron's just turning a corner in time. It doesn't actually get annihilated with a positron. It just reaches a point in time where it stops going forward in time, starts going backward in time. So according to the electron, it's still itself. It's just that time is going backward now. But a photon had to come out in order to do that. I guess it had to expend a lot of energy in order to turn this corner in time. So maybe the reason why it's so hard to make copies of yourself is because you probably have to expend a lot of energy. V equals mc squared. If you're going to need 10 copies of yourself, you'd have to expend the amount of energy equivalent to 10 times your mass, which is a huge amount of energy. So maybe it is possible. Maybe it just involves a lot of energy. We don't know yet. But anyway, and then I think another one, here's one of the most convincing paradoxes against time travel. Why haven't we seen any time travelers from the future? I mean, if time travel really were possible, you'd think we would have been able to do this. I mean, you'd think, people from the 25th century who can travel back in time, why wouldn't they be visiting the birth of Christ? Why isn't there a big tour group visiting Bethlehem around the time of the birth, or Nazareth, the time of the birth of Christ? You'd think there'd be thousands of tourists flooding that area. And that didn't happen. We never recorded that in history, and other big events too. Why haven't we seen that? Maybe there's a directive that forbids them from doing that, or maybe we wipe ourselves out before we have a chance to learn how to travel back in time. I hope that's not the reason, but there are possible explanations for this, and I don't know what to believe myself. I guess I'm sort of under the idea that maybe there's a directive or something. And maybe we have actually met people from the future, but they're very discreet about it. They don't want to make it obvious that they're from the future. But I'm not from the future. At least as far as I know, I'm not. And if I were, I think I made a big mistake coming here. I'd rather have stayed where I started in the 25th century, wherever it was. But I don't know if any of you guys from the future, if you are, tell me so, and we can talk about what the future is going to be like. But anyway, and then the fifth, actually, probably the weirdest time travel paradoxes are the sexual paradoxes. And I've actually read some really weird stories about sexual time travel paradoxes. Probably the weirdest one. There's a very famous sci-fi short story by Robert Heinlein. He called it "All You Zombies," and it's the weirdest story I've ever read in my life about time travel. And it does involve a very, very weird sexual paradox where this guy is both his own mother and father. And I'm not going to even explain how that happened, but you'll have to read the story to see for yourself. Pretty weird. Uh, and what else? So those are I think those are the only time travel paradoxes I know about. There are probably some other ones too, but because of all these paradoxes, for a long time people thought time travel was impossible. But there are ways around all of them. I think the hardest one around is actually the fact that we haven't seen anyone from the future. But anyway, but multidimensional. I think this is really, I mean, lately, the idea of parallel universes has been gaining a lot of popularity. And I think it's a really intriguing idea. Now there's a lot of stories about alternate histories. I mean, there's some sci-fi series about what would have happened if the South had won the Civil War. There's a lot of movies about what would have happened if the Nazis won World War II or if World War II never happened. There's a really good movie came out a few years ago called Yesterday, which was this guy goes to a parallel universe in which the Beatles never existed. I love that one. You can have a lot of fun with these things. What I don't know, I mean, so it seems like if we were able to go back in time, we'd end up changing history, and if we went back to the present, we'd be in a parallel universe. What I don't know is whether you could ever go back to the universe you started in. That'd be great if you could. Because then, if you mess things up too much, you could always go back to where you started, you know. But we just don't know. I mean, all of this is speculative at this point. However, I think I should just point out one more thing about all this. Our two current big theories of physics right now are general relativity and quantum mechanics. And both of those theories actually predict various forms of time travel into the past. I think it was Kurt Gödel, the same Gödel who proved two incompleteness theorems in mathematics, very famous logician. He also was able to find the first solution to general relativity in which time travel into the past was possible. And he showed it to Einstein, and Einstein was very impressed with this. And since we've discovered a lot of other possible mechanisms for traveling into the past in general relativity, I think the most commonly known one is wormholes, and it looks like this picture here. It looks like this time travel is going into a wormhole. So wormholes have been used in a lot of sci-fi stories in order to travel back in time. They use it in the movie Contact, I think, and a lot of other movies, and they are kind of intriguing. But we just don't know. I mean, this is pure general relativity. There's also things in quantum mechanics that might allow for time travel in the past. If you could create these false vacuum bubbles, supposedly those allow you to travel back in time into the past as well. But we don't know because we don't know how general relativity and quantum mechanics mesh up with each other. And there could be some kind of cosmic censorship. I think there are a lot of physicists who believe this right now. They think wormholes aren't stable, so we couldn't use a wormhole to travel back in time. We just don't know yet. I guess the jury's still out on whether it's going to be possible to travel back in time, or even whether parallel universes exist. I think they do. I do believe in the multiverse. I have a lot of reasons to believe that, which I don't want to get into, but they're based on what I know about physics. Anyway, that's multidimensional travel, and that's number two on my list. So, what do you think's number one? Anybody? Number one is eternal youth. And this idea has been around for all of human history, at least all recorded history. I mean, the ancient Greeks, and I think all the ancient cultures had myths about eternal youth. And who wouldn't want eternal youth? I mean, nobody wants to die, nobody wants to get old, and nobody wants to die. We all wish we could stay young forever. I mean, kind of a natural wish, right? I mean, I'm 62. I don't feel like it, but I'd rather be 20. I'd still rather be in my 20s, and I'd still rather be, as sexually active as I was in my 20s. I wasn't able to do much with it when I was that age, but now I think I could. Unfortunately, I don't perform as well as I did 40 years ago. So I've kind of missed that boat. I wish I hadn't, but eternal youth would have served me pretty well. And I'm sure it would serve a lot of us, the rest of us, well too. We all get old and we all die. It's sad. Nobody wants to die, but it is a fact of life. And they used to call this the fountain of youth. But what's wild about this to me, I mean, it was just pure fantasy for most of human history. But I'd say in the last 20 or 30 years, it's much more plausible that we could really get this. I mean, we've already isolated the genes that are responsible for aging. They're what are they called? Telomeres, I think, something like that. I gotta look it up. Um, can't read my writing here. It begins with a T. I wrote it down. But there are genes associated with aging, and if we could control these genes, maybe we could stop aging. I don't know. I don't know. I mean, we can live a lot longer than we used to be able to. It's pretty wild that, like primitive man, cavemen, only lived about 25 years. Ancient times, if you look at life expectancy throughout history, I mean, most of human history, life expectancy wasn't very long. I think even just 200 years ago, it was like maybe 40 years. And it exploded in the 20th century due to improved medicine and sanitation. Now, I think in most of the developed world, the life expectancy is at least 80 years. In the United States, it's actually going down a little bit because we're doing things really shitty. Our healthcare system's falling apart. But at one point, I think it was up to 79 years around 2010, and now it's about 76 years, unfortunately. China has a higher life expectancy in the United States right now, which I think is really appalling. But I mean, for the most part, we've been living longer and longer, and maybe at some point we'll be able to stop aging entirely. There actually is a guy who believes this is possible. I think his name is Tom Wolfe, and he wrote a book called The Longevity Escape Velocity. He thinks that even I went to a lecture of his about 10 years ago. He said at this time, this was around 2010. He said that by in 25 years we'll be able to stop aging. We'll be able, in principle, live forever. I mean, I think he was full of shit, but not 25 years, but maybe 200 years from now we'll be able to do this, or by the late 22nd century, I think we probably will. We'll be able, at least in principle, to live forever, at least until we have an accident. We won't die of old age anymore, or of disease. We'll die of accidents. We'll die if we get in a car accident, or we'll die if a spaceship explodes, or whatever. But we won't die because our body fails. And that'll be pretty wonderful. And if you think this is pretty far out, I don't know how many guys realize that alligators, and I think crocodiles too, they don't age. They don't have a life expectancy, they have a lifespan. They keep growing. Not only do they not get old, but they keep growing until they meet with an accident. I guess until they get eaten by another animal or something, or bitten by another crocodile. So they could, in principle, live forever, as far as we know, if there were no predators out to kill them. So maybe at some point humanity will get like that too. But then that opens up a whole bunch of kind of philosophical and ethical issues. Do we want to live forever? I used to ask my question this a lot. And I don't think I would. I think I'd get bored after a while. I don't know if I'd get bored or I don't know. I think I'd reach a point at some point, maybe after 200 or 300 years. I think I'd reach a point where I don't want to live anymore. Because I've learned everything I want to learn about life, and I've seen it all, and it's fine. I'm ready to go. And that might happen more in the future. I don't know. I mean, I wouldn't be surprised if by the late 22nd century euthanasia becomes really commonplace, where we just drink some poison at the end of our life, maybe after 120 or 150 years. Once we've had enough, we just drink a vial of poison, say goodbye to all friends and loved ones, and just leave the world. And I do believe in reincarnation, by the way, so maybe that's such a bad thing to do. I don't know. I don't want to do it in this lifetime. I want to live out my natural life span, and I'd like to see the world get better before I die, hopefully. I'd like to see the world's first fusion power plant get built, hopefully by by the year 2049, like I predicted in my first video. I'm not ready to go. I'm 62. As a matter of fact, I used to be much more suicidal when I was young. When I was in my teens and 20s, I didn't want to live anymore just because I was so depressed. But I haven't been depressed for over 20 years. I love life now, even though it does present a lot of challenges. And I want to live out my full life too as long as I can. And I want to enjoy the rest of my life. And I hope you guys do too. Anyway, that completes my series on future inventions. And thank you, and keep thinking. And I'll see you guys next time.